Hi, in this video I'm gonna show you how to load a custom dataset using pytorch and also know how it works under the hood. We have this custom dataset which is wine. It's very popular. The label is in the first column and the data in the other column. Okay, so we start by importing torch, and also we need to import the utilities from torch dot utilities. What's going on? From torch dot utilities dot data. Anything that you need to work with data, you will find it in the utilities data, even the dataset or the built-in dataset that you usually learn with it. But here we are trying to load a custom dataset, then start building the machine learning or deep learning models using pytorch on this data. So from this we need to import a data set class and also the data loader class, which we gonna use to load our custom datasets. To build any custom dataset in pytorch, you need to make a class and inherit the dataset class and start implementing two main functions. We will see them together now. So we need to name this wine dataset. You should name it anything you want, but it should relate to what your dataset is. And here we implement or inherit this class, and we're gonna override two methods. But we will start by defining the constructor, which is self, and here in this constructor you should load your data, okay, and divide it to labels and features. But you need to return those label and feature as tensors, since you are working with pytorch. We will find a way to do this, but as our data is in CSV file, you can try to load it as any using any library that you find fit, but I'm gonna use Panda here. You can use also NumPy as bd, and in Panda there we have a function bd.load.read CSV file, and we should pass the okay. We have here our data. We need now to divide it to two parts. So we can make self.data and self.x, and here we need to take iloc from, I need all the rows, and from the first column and on, to remove this column, okay, and this will be our x. And for y we will do the same thing, iloc all the rows and only the first column. But there is something here in pytorch. You need your data to be, your y should not be as I'm writing now. It should not be a list, it should be list of lists. It should be like this, okay. If you have one label for each example, okay, it should be 2 dimension. NumPy.array, it should be like this. So what you can do here, you can add another dimension like this, or you can do reshape and make it -1 and 1, as you need it in one column, because this will return a list without this brackets. Okay, so we need to make a small change, which is this is a data frame and this is a series. We need to convert them to numpy. So there's a function called toNumpy. We need the IntelliSense here to help us. Okay, it's sleeping now. I wish I'm writing it correctly. Okay, before that we need to make here also small change. We have here the numpy array and here the other numpy array. We need to convert them to tensors, so we have torch dot from numpy, and we have to path the numpy matrix, and we can use dtype equal torch dot float 32. We should do the same thing for the y. Okay, we torch dot float 32. Okay, so we converted our data. Next we have to implement the two functions that we have. The first function, which is get item. Okay, so let's write it down. Get item, which also takes self, and it should take the index of the items that you want. Okay, we can okay, into the matter. We should go ahead and return we should return a tuple x dot index and y dot index. That's it. And here lastly we should do the override the length and return we should return the number of samples. So if we get data.shape of 0, it should return the number of sample from this dataset. So far so good. Okay, let's try to use this. Our dataset yn dataset. Okay, let's solve our problem. The name data is not defined. Self data. Okay, self dot data. Self dot data. Torch from numpy take no keyword argument. What is this? From numpy it should take. I don't think we made any mistakes here. Torch variable function clause from numpy take no keyword argument. I didn't. He says it doesn't take this. Take exactly one argument. I see. I see. To numpy. Okay. It should work now, but I don't know if it's gonna be float 32 or not, but we can convert it. Now we can convert it. Okay, let's see our dataset. If you pass this, it should return, and it should use this function, the shape length once, I'm sorry. It worked fine, I think. It returned two things, the label and the feature of this. But if we pass a patch, like let's say we have a patch of 32 element, it's gonna work and it will return a 32 element. Length. It should return the top, so it's working. And 5 should it also work. So what we can do next is discuss this function, why you pass a slice and you only using an index. It should not work like this. You should pass an index to work. Let me explain more. If you have a function get item and you pass index, and you have here let's say this list, you have this beautiful list x, okay. Alright, so returning x.index will only work if you pass single index. Get item, passing index, turn from x. Why is this not working? Okay, it starts to work now. We can make it more visible. Alright, if we pass like we did here we did this and it worked, okay. So why if we do the same thing here and pass index work, but if we pass a slice it doesn't work? So to pass a slice you should do something like this, slice of 0 and 2, and it works. So under the hood, this get item in this class, it use the slicing function to give you a slice if you pass a slice like this. Otherwise it would be like this function, you have to only pass specific index, okay, otherwise it will not work, okay. Even if we did it like this, it will still not work. Like this, it also will not work. So we think we understand it now. Now let's try to load our dataset. I need to check the type also. Let's give us some time to check the type. Dataset, I need the first. Okay, we need to load it first. First index. And what we need to do is I need to use server.x, and here's server.y. Also here you need to use self. Alright, everything works fine now. And the data type float is 64. Okay, let's load the dataset using data loader. Data loader, we should pass the dataset, and let's see what does take. It should take a batch size. We will pass. We need each batch size to be 5, and also we need to shuffle. As you see here, there's shuffling and number of workers for parallel loading of data, but we will not do this. We need to shuffle. And what else? I don't think we need anything else. We need batch shuffle. Okay, that's it. Okay, what's wrong now? Okay, we have cell here. Everything work fine. We need to iterate now over this patch loader. We can make something like this because we need only to see a patch data loader. We need to find the next, and let's see it. Okay, so 1, 2, 3, 4, 5, and it's a patch of 5. If we want to see the shape of it, of course it doesn't have the shape. We need to item here. I see, it doesn't have a shape because it returned 2 things. It should have it should be a table of 2 things, which is features and labels. Okay, we can now check the shape of features, and we find it at 5, and we also check the feature, the label shape, and we find it 5.1. If we didn't do this, we check the label feature. It is not right. If you did it this way, you have to use your label, or you have to reshape your label before using it in any machine learning or deep learning class like this. Okay, but we will do it like this. Alright. If we need to NumPy, if you need to change the data type from 64 to 32. Okay, let me stop the recording right now. Everything fine so far. I will search how to converting the data type, and write it and comment if you need it. Okay, just for completeness, what I did to convert the 64 float to 32 is converting the type of the torch using this way. Okay, so why I convert it in the first place? Because working with 32-bit number is more easy for the processor, and it's more faster than working with larger numbers that we will not use. That's it, and I hope you got anything from this long video. See ya and bye.